All right, let's work through a few samples with naming. We've got some practice questions right here, and we've got CrBr3. So let's go ahead and find those on our periodic table. The Cr is going to be chromium, and the Cr is right here, and it's a transition metal, so it has multiple ionization states. And Br is bromine, and that is over here. It's a non-metal, so we've got a metal and a non-metal, so it's ionic. This has multiple ionization states. This is only going to accept one electron, so it's going to have a -1. This bromine is going to form a -1 ion or anion. So we've got 3 bromine. Each bromine is going to want 1 extra electron. So that, and we look over here, there's only 1 chromium. So we know that this chromium must have given away 3 electrons because each bromine can only take 1. So since it's given away 3, we call it chromium 3 bromide. Don't forget about that IDE in the end. All right, SNS. SNS. All right, so SN is tin, and you'll find tin over here. Tin has kind of a poor metal. It has multiple ionization states. And S is sulfur. It wants to get 2 electrons. So it's going to form, the S we know takes a -2 state. So it'll take a 2- charge, this ion. So that means that the tin must have, since there's 1 S for each tin must have given it those 2 electrons. So the tin forms a 2+ cation, and so we know this is tin 2 because the tin has given away 2 electrons, and sulfur, right, sulfide. CuF, Cu is copper, fluoride, fluorine is a halogen. All right, we'll find fluorine over in this first column over here. So it has a 1- ionization state. So there are 2 of them. So, right, if we were to look at a dot diagram of fluorine, it would have 1, 2, 3, 4, 5, 6, 7. We know there's 2 fluorine, so there would be another one down here. Sorry, I'm just crunch it in here. And we've got 2 gaps, right? We have a gap right here and a gap right here. So each one of these wants an electron. The electron we know came from a single copper because it just says Cu. It doesn't say Cu2 or Cu3. It just says Cu, so there's only a single copper there. So that single copper must have donated 2 electrons. So we know this is a copper 2 fluoride. All right, so there's a couple of examples where we have our transition metals with multiple ionization states. Let's go ahead and we'll do some metals with polyatomic ions for practice. So let me pull some of those up here. So we'll start off with a tough one here. This one, there's a whole bunch of atoms in it. When you've got something like this, especially because it's not starting with a metal, right? It's starting with a non-metal. We've got a situation here where both of these are actually polyatomic ions. So if we look at our cheat sheet here, we see them all listed out here. This is not all of them. It's many, but it's not all of them. So we have NH4, ammonium, and HCO3. So we look at our list and we find HCO3, bicarbonate. So we have ammonium bicarbonate is the name of this compound. Right? Next, CuSO4. Cu is a metal, right? SO4. So we know that this is a sulfate, right? If we take a look at our sheet and find SO4 on here, we have sulfate. Okay, so this is, it needs 2 electrons, so we could do Cu, copper. There's one sulfate group needs 2 electrons. There's 1 copper. They must have given it 2 electrons. Copper 2 sulfate. Next, NaC2H3O2. Well, we have a lot here, but this first one here is a metal. Right? So since it's a metal, we're pretty comfortable in saying that this is our polyatomic ion here, and the metal is a cation by itself. So this is going to be sodium, right? Na is the symbol for sodium, and we've got C2H3O2. We look at here, and we see that it's acetate. All right, so we go back to the other one, and we have acetate. All right, so that's a basic example of naming polyatomic ions.